The three factors that determine the type of work a motor can produce are speed, torque, and horsepower. Speed is defined as how fast the motor performs its work. For example, a shaft can rotate slowly or quickly. The typical units of measurement for rotational motor speed are revolutions per minute or RPM. Work is defined as a force applied over a distance. In the case of flywheels, winches, and motors, the work is called torque. Torque is a special type of work that produces rotation. Torque occurs when a force acts on a radius. Typical units of measurement for torque are pound-foot. The torque illustrated here is equal to 1 pound-foot. Horsepower is defined as the rate at which work is accomplished. Years ago, before motors were invented, most work was accomplished manually. It was estimated that one horse could accomplish approximately 33,000 pound-foot of work per minute, and thus the term horsepower was born. In modern terms, horsepower is simply another unit of measurement for power and can be translated into watts, BTUs, joules, or any unit of power. Units that measure motor power are typically in horsepower or watts. You can manipulate the connection among speed, torque, and horsepower by understanding how they are related. The work accomplished here, the torque, is represented by the weight moving along the conveyor. If torque remains constant, speed and horsepower are proportional. As the speed or RPM increases, horsepower increases to maintain constant torque. If speed decreases, horsepower decreases to maintain constant torque. Let's say we wish to keep torque constant but want to increase the production of barrels. If the torque or number of barrels on the conveyor belt remains constant but speed increases, then the horsepower of the motor also increases. In other words, a more powerful motor is required to produce the same amount of torque more quickly. Similarly, the opposite is true. If we wish torque to remain constant and decrease speed, then the horsepower of the motor also decreases. If speed remains constant, then torque and horsepower are proportional. As the torque increases, horsepower also increases to maintain constant speed. As the torque decreases, horsepower also decreases to maintain constant RPM. Let's say we want production to increase, but the speed of the conveyor to remain constant. If torque increases, horsepower also increases to compensate. This means a more powerful motor is needed to produce more torque at the same speed. Similarly, the opposite is true. If we wish speed to remain constant and decrease torque, then horsepower also decreases. If horsepower remains constant, then speed and torque are inversely proportional. As the torque increases, speed decreases to maintain constant horsepower. As torque decreases, speed must increase to maintain constant horsepower. Let's say we want the horsepower of our motor to remain constant, but wish to increase the torque. If torque increases, the speed of the conveyor decreases so that the horsepower required of the motor remains constant. Similarly, the opposite is true. If the torque decreases, the speed of the conveyor increases and the horsepower generated by the motor remains constant.